Welcome to the session. I'm Professor Adana, working as an assistant professor in the Department of Mechanical Engineering, MIT, Mysore. In this session, we will be moving on to Module 4 of the VTU syllabus for the subject Operations Management. So in this module, we will be studying in detail what is Material Requirement Planning, abbreviated as MRP. So you imagine a car industry or any automobile industry. So if we take a large car industry, we know that there are a lot of sub-assemblies, there are a lot of other raw materials, other dependent parts that will go into the assembly of a car. For example, we know that before a car is rolled out or before a car is sent in for dispatch, we have a lot of production activities that take place. One of which, if we name them, we know that we have a brake assembly, we have an engine assembly, we have a casing, we have doors, we have windows, we have seats. All of these need to be assembled. So we know very well that before one car is manufactured and sent out into production, we know that there are so many other components that have to be included or incorporated into the same system before production takes place, before dispatch takes place. So in such a case, what do? We have to make sure that all the items are available. Now, one more thing that we can understand, or one more thing that is practically known to each and every one of us, is that every single part or product that goes into the manufacturing and assembly of one particular car, before it goes into the market, it is not possible for us to keep all the components in the factory. It is not possible for us to keep all the assemblies, sub-assemblies, everything in the factory while carrying out the production process. Why? Because of financial and space constraints that we will face. So certain inventory products, we might be spending a little more because they might depreciate and need to be available only when manufacturing is taking place. So in such a case, what we need to do is, we need to prepare or have a system that will tell us exactly when we need to carry out, or we need to procure, we need to acquire, or we need to purchase a certain part. It could be a raw material, it could be a sub-assembly, whatever it is. Now, when a particular item is dependent on another item, for example, for the car to be manufactured, if there is a particular kind of chassis that has to be manufactured specific to that particular car, if it is specific to the product, the demand for this chassis that we are going to be manufacturing is dependent on how many products or how many pieces of the car that are going to be rolled out. So in such a case, this becomes a dependent demand. Now, when we are referring to dependent demand, one thing that we need to always bear in mind is that these dependent demand items are not procured and stored. They are procured at the time of manufacturing. How do we do this? We have to have a system. And this system has to tell us when exactly we need to procure these items, because we cannot store them because of financial constraints and space constraints that we may face. Now, the way we have to order these, or the way in which these have to come into the system, have to be such that work does not stop. It does not stall the work that is already in process. So in which case it should be available right on time. Now, for us to be able to purchase these or acquire these right on time, we have to use a system that is called as a material requirement planning system. The name itself suggests that we plan the amount or number or quantity of the material that has to be got right on time. We plan it along with the timing, looking at when it is required in the system, and then we place an order and it has to be in the system by that particular time, so that we are able to carry out production as per the schedule. So to define material requirement planning in general, it is a system of planning and scheduling raw material requirements for production operations. This could be any kind of production operation. So for whatever be the production operation, when we are trying to figure out and schedule how to produce or procure these raw materials just in time for the production, then we use a system called as a material requirement planning system. The specific definition of an MRP system is a technique that is used to determine Very importantly, the quantity and the timing. The quantity and the timing of acquiring dependent demand items. Please make a note of this. I will be defining what exactly dependent and independent demand items are, but please keep this in mind. It is the technique that is used to determine the quantity and timing of acquiring dependent demand items. What do we mean by dependent demand items? Dependent demand items are items which are going to be ordered depending on something else. Depending on the kind of assembly I'm creating, I will procure certain type of raw material. Otherwise, I don't need it. So when it is when the demand of a particular item is dependent on something else, we call it as a dependent demand. And when I need to procure this, the timing and how much I need to procure, the technique that I will use to determine these two important factors is called an MRP system. Now, where are we going to use this, or why is it important? We are going to use this only to satisfy the master production schedule requirements. So in the MPS, we will have what has to be procured, how much it has to be procured, when it has to be procured. We use an MRP system to get these specifics in order to satisfy the master production schedule requirements. So this is the definition of the material requirement planning. Now we will try and understand the two terms that are associated with MRP, which are dependent and independent demand items. Now let us understand the two types of demand that we face. We have dependent and independent demand. Now these are two different kinds of demand, but they are both very important. Why we need to understand this is because dependent demands and independent demands for products will determine when we need to procure the same. So if I have to define a dependent demand or a demand for a dependent item depends on something else. It is a function of another property or another product. For example, in an automobile industry, a particular demand for a subassembly or a part will only depend on whether I am going to use that part for the manufacturing of the final product. Like if it is the subassembly of a car or an automobile, depending on the number of automobiles that I am going to be producing in that period of time, I will procure only those many sub-assemblies or those many parts that are required for that particular automobile, and I will procure it only at the time of manufacturing. So when the demand for that sub-assembly or that part is dependent on something else, like it is dependent on another part or the main product that is going to be manufactured, then it is called as dependent demand. So a dependent demand is a demand that works only depending on the final assembly or the final product. Now here, if you have to see and understand, I have divided it into two. Independent demands are stable demands. So independent demands are generally the final products, or you can say the very basic raw materials like nuts, bolts, washers. All of those things are independent. Whether you are going to use it in a short time or not, it will be produced and kept. It is procured and kept. Those are very basic things that are required in the organization or in the industry. Whereas specific types of bolts, specific types of fasteners, specific types of nuts and parts can get into dependent demand depending on what kind of product is being manufactured. So here, if I look at this, the dependent demand and the independent demand is a stable demand. No matter what happens, the demand is stable. It is not scattered. So it just keeps being, whenever it is over, it is ordered, whether it's going to be used or not. So the demand against time is always there. We are always procuring that quantity which we always procure, depending, and no matter the time, the product is always available in the organization or in the factory. Whereas dependent demand, because it is dependent on something else, only when required we place an order. And the number also and the quantity also differs, because sometimes I need more of it, sometimes we just need very less. It depends. So this kind of a demand is also called as a lumpy demand. a lumpy demand or a sporadic demand or an irregular demand. It is not the same always. It always differs from how many products you're going to manufacture and how many pieces you already have. So here, against time, when you plot the dependent demand, it is a lumpy and an irregular demand. You don't see it as a regular demand here. Okay, so here why I have not shown the stable demand as a straight line, why I have used a wavy line is because here also it is procured, used, it's consumed at all times. So it just keeps going. Though it is being used, we are not using it as a constant linear line. It's not a straight line. And in the sporadic and irregular, it's clear from the graph, only when required it is ordered. Another thing is, here, independent demand is always required continuously. It is always required. Grease, oil, paint, these are continuously required, no matter what the product is. Paint, grease, oil, nuts, bolts, screwdrivers, these are all things that have a demand at all times. So here what happens is, for the consumables, what we do is, we always order a safety stock. We have some stock that is always available. So beyond this safety stock, there is an order that is placed. Say for example, for production of 100 plumber blocks or 100 screw jacks that we use in the automobiles. Say for that you need some 100 or 150 different types of parts. Or even if we take a very basic lot of 10 different parts that are needed, a spring is needed. So at all other times, if we consider the spring to be an independent demand, we will have a safety stock of, say for example, for 100 pieces of the screw jack, maybe we are going to have 100, we need to use 100 springs. So here, in those 100 springs, we will have a safety stock of say 50 springs in case of failure. So apart from 50 springs, we will order extra. So we will be ordering 100 springs or 150 springs, but the safety stock is always required. In independent demand, safety stock is always required. We always will have a buffer because the demand for these items is continuous in nature. It never diminishes. We always need it no matter the product. So here you will have a safety stock. Beyond the safety stock, we have orders. So once the order is placed and the order arrives, the lot arrives at the shop floor, here it is used, it diminishes, goes down up to safety stock, not beyond that. Again we place another order, it has an arrival time. Once it arrives, again we use it up to safety stock. Then again we place another order. Once it arrives, we use it up to safety stock. This is how independent demand goes. Dependent demand is not like that. We place an order as and when we need it. Say for example, I require a lot of certain amount of raw material to be available to me at the 4th week of the production schedule that we have. If I have a production schedule of say around 8 weeks and I say that in the 4th week I require a certain raw material. So I will determine what is the time that I need to take that it takes for the raw material to arrive at the site of production, and I will place an order accordingly. Whenever the order arrives, it is used immediately and completed. Then we wait for the next time that we require the order. It is used immediately and declined. There is no safety stock. We do not order, we do not save, we do not stock up, we do not store. This is because it will incur certain financial conditions that we will have to have. Now here, note the difference. The available on hand, with the independent demand, you always have to have some safety stock available on hand. Used, ordered again. Whereas in the dependent demand, you do not have safety stock. You will have to order it as and when required. Once it arrives, it is used. Then when it is required, if and when it is required again, the order is again placed. So this is the difference between dependent and independent demand for products. Now why is this important? Because the MRP that we are using, the material requirement planning, helps us to determine the quantity and timing for these. That is for the dependent demand, because independent we already will have it always. So to determine this arrival time, this usage time, when we need to place the order for it to arrive on time, is where we use material requirement planning system. That is why it is important for us to note the concept of independent and dependent demands of items. Now let's just see an overview of this MRP system. So MRP system initially in earlier days was a handwritten schedule system in which people made these schedules by hand. So virtually they tried to calculate, they tried to forecast and try to understand exactly how and how much time would be required and how much of material would be required, and this scheduling was carried out by hand. It was a handwritten process. Now this became a very tedious process, and hence with the evolution of computers and the introduction of computers, the process of MRP was again re-looked into. So now the MRP systems that are available are computer software programs. There are different types that are available. So there are different types of software packages that are there for calculating the material requirement. So using these software packages that are stored in computers, we carry out MRP planning, that is material requirement planning process. Now, what exactly is this material requirement planning process, or what is this package all about? It is a package that converts certain input into output. So this is something very basic that we all know, that there is an interface or an intermediary or an intermediate stage that takes in some input and gives it as an output. In this case, the MRP system takes a certain input and gives us required output. So what exactly is happening here? It has input. Okay, so this input is fed into the MRP system, processing takes place, and that gives us a generated output. Now exactly what is this MRP doing? The master production schedule tells us how much of final goods are required. What is the final level of goods and services that are required to be given? Now when this is decided and when this is given out to us through the MPS, the MRP tries to break down whatever prior assemblies, sub-assemblies and components are required for the same final component available in the MPS. In other words, if at all I require, even in the manufacturing of a simple chair, I require 4 legs, I require a backrest, I require a cushion, I require armrest, whatever be the requirement. Final requirement given to us by the MPS is a chair. What does the MRP do? The MRP divides this into different components, smaller components that will contribute to the chair. Now all these smaller components that it is dividing them into are dependent demand items. The leg of the chair is very specific to the kind of chair that we are trying to make, or the kind of chair that we have been asked to produce. So here the MRP divides this component into smaller components. In other words, it works in the reverse order. It starts with the final schedule that is required or given to us by the MPS and goes on to give us basic raw materials of wood, right up to the wood that is required for manufacturing. What are the 3 main inputs or the 3 main things that are required for this MPS? The MPS requires, what are the three main things that are required for an MRP system in that case? The orders that have been placed and the forecast, which will tell you when exactly these orders should be available. These two are fed into the master schedule. It will give us the final order that is required and when it is required. Then bill of materials. Bill of materials will tell us what is the design, what kind of product, how many of these products, how much raw material. That is in the bill of materials. Bill of materials will tell you this. Further, we have an inventory record. An inventory record file will give us how much on-hand material do we have. Do we have anything? It takes receipts. If there was an earlier order placed, which is yet to come, it will tell you from the inventory records. And if there was something that was taken out from the stock, that will tell you from the withdrawals, again in the inventory records. So basically what is an MRP system doing? It is answering the 3 questions of what is the final requirement, when is it required, how much quantity is it required in. MPS will tell you, I want 100 chairs. MRP will tell you, what are the raw materials required for you to procure or produce 100 chairs within the time specified in the MPS, and exactly when should you place the order so that it is available on time for production. When these three inputs are fed into the MRP system, computer programs and software packages that are fed into the MRP system work out three different types of outputs that we will use. The first output is a primary report. It will generate a primary report. This report will tell you about any changes that are required. It gives you an order release, in the sense, when should the order be released. If I tell you, or if I give you information that a particular order takes 4 weeks for realization, that means if I tell you that 4 weeks, it takes me 4 weeks to deliver a particular product, it means that there is a lead time of 4 weeks. Simple meaning, you will have to place an order for that product 4 weeks prior. Because it takes 4 weeks to reach you, you have to order it 4 weeks in advance. That is all that it means. So when should the order be released? Then also tells you planned order schedules. So order releases can be sudden order releases as well, and also planned order release schedules. So it allows you to plan exactly when you want to place the next order. So the next one is the secondary report. A secondary report is the performance control report, the exceptions report, and the planning report. So here it tells you exactly how the MRP is performing. Are we able to meet the production schedule as planned? Are we falling back anywhere? What should be the changes that are made? That will be informed in the secondary reports. And finally, it tells us the inventory transactions that are taking place. Inventory transactions, that means what is the receipt? How much do we have on hand? Are we going to expect some number to enter into the inventory anytime soon? And has anything been taken out? So after all of that has been done, what exactly do we have in the inventory? All those transactions are an interface between the MRP and the inventory records file. The final feedback from the inventory transaction is fed back into the inventory records file, which again updates itself in the MRP system. This is an overview of the MRP system. Now we will see the three inputs to the MRP. The material requirement planning system has three major inputs. The first is a master schedule. The second is a bill of materials file, abbreviated as BOM. And the third is an inventory records file. So exactly what happens in each of these, we will learn in detail. Now, if we start with the master schedule, as the name suggests, tells you exactly how many items or how many numbers of what quantity of a particular product is required, when it is required. This is the master production schedule. So this schedule will tell you what is the lead time, when exactly should the material be processed, when exactly should the raw materials arrive at the shop floor. So if you look at this table, a master schedule has a particular pattern. The week number, month number, or production schedule number is represented in the form of columns, and other items are represented in the rows. So for this example, we have considered an item named X, and the weeks of production are 8 weeks of production. So if I look at the master schedule for this item X, it simply means that production will begin in week 1 and end at week 8. Now, exactly what is the quantity or what number of item X do we require? Item X is required in quantities of 100 at the beginning of week 5 and 150 at the beginning of week 8. That is what this means. Now, what exactly does this imply? It means to say that each and every week, we call each of these weeks as time buckets. So time buckets are small time periods or small periods of time which divide the entire production schedule and tell us exactly when we require to procure the material that we are talking about. So according to this table, I repeat, 100 units of item X are required at the beginning of the 5th week and 150 units of item X are required at the beginning of the 8th week. Now when these two weeks will get their required demand will determine on the lead time for procurement of whatever this item we are talking about. For example, if it is that this item has a lead time of 4 weeks, then if I need it in week 5, I will count 4 weeks backwards, that is 1, 2, 3, 4. I will have to place the order in the first week so that it will reach me in the beginning of the 5th week. Again, if I want it in the 8th week, I will count it backwards 1, 2, 3, 4. I will have to place an order in the 4th week so that I will receive it in the 8th week and so on. So this is a master schedule which gives us exactly what we need finally. And going on to the bill of materials, that is the second input. Here you see that this gives you what we call as a product tree. A product tree is a detailed structure of the finished product. So the finished product is taken from the MPS, like for example in this case item X. So it has been told that 100 units of item X are required at a particular time period. Now if I consider this item X to be a finished chair, the bill of materials will give me details of what are the parts involved in making of this finished chair and how many of each of these parts I need to procure, where are the sub-assemblies, how many sub-assemblies are required. So if you look here, this is a product tree of a finished chair. For me, I am considering this to be item X. Now every unit of the finished chair, this tree is given for a single unit. Every unit of the finished chair requires 2 front legs, 1 seat, 2 back legs. This is the requirement of item X. 2 front legs, 1 seat, 2 back legs. This is the basic requirement. Okay. So further if you see in the MRP, it will break this again. 2 front legs will be joined by 1 crossbar. 2 front legs will be joined by 1 crossbar. So if I try to imagine exactly what this tree is telling me is, I have a finished chair and I am going to have 2 front legs joined by 1 crossbar, 2 front legs joined by 1 crossbar, 1 seat, 2 front legs joined by 1 crossbar, 1 seat and 2 back legs. So 2 back legs, Now these 2 back legs have back supports. So they have 3 back supports. These 2 back legs have 3 back supports. So it means there must be a railing somewhere here. Then it has 1 crossbar that is joining the back legs, 1 crossbar. Then it has side rails. So this is exactly what I want finally. Each unit of this will have all the components that are listed over here. So the bill of materials file gives you what we call as a product tree, and with this product tree we calculate exactly how many of each of these smaller products that we need to procure. Understand this, that in a product tree, whatever is at the base or the lower end is called as a child of the previous one, which is called as a parent. For example, the back legs are the parents of back supports, crossbar, side rails. They are the parent components of these. And back supports, crossbar and side rails are child units of the back legs. Similarly, front legs, seat, back legs are the child units of a finished chair, that is in this case X. So to further understand bill of materials in more detail, we will solve a few problems.